This is the second video on statistical diagrams for the AQA A-Level Maths 217 specification. In this video we're going to look at cumulative frequency diagrams. The Excel file referred to here will be used in the lesson on this that follows on from the video. We looked at stem and leaf diagrams in the previous video and showing how they displayed very effectively simple raw data. The data we're now going to look at with cumulative frequency diagrams is grouped frequency data. It's really useful for working out things like the median, the quartiles or other percentiles. We're going to look at this information here. You see projected population in the UK for 2005, so everyone from 0 to 10 years old in this category here, then from 10 to 20 here, bearing in mind that 19 right up to your 20th birthday you would be in this category here, from 20 up to 30 in this category, and so on. Why do we have a 0 here? Well, bear in mind that all of this data here is to the nearest million, so it's rounded, so clearly less than 500,000 in this category. The actual fact, we've got 113,000, so it's rounded to 0. For the purposes of the diagram, we're going to ignore that group and just work up to 90. First thing we need to do is accumulate the frequencies, so we need a cumulative frequency column here. Up to 10 we have 7 million, up to 20 we have 15 million, accumulating the 0 to 10 and 10 to 20. 22, the additional 7 million between 20 and 30 from here, and so on. Some important points. As we've explained, there isn't really a gap between 9 and 10. It looks like there is, but clearly, as I said before, anyone that's 9 years old and right up to their 10th birthday, it's continuous data, so we don't need anything between there. We use the upper class boundaries to plot data for cumulative frequency graphs. Normally we would look between 9 and 10 and we would have the upper class boundary at 9.5. However, as it's age data, we know that everybody up to 10 is in this category. Everyone between 10 and 20 is in this one. So we'll just have it at 10, 20, 30, 40 and so on. Bearing in mind that we're counting everyone up to their age, it's these figures here. So everyone up to that age will be counted. So that's the upper class boundaries we're going to use. Okay, ready to go now. There's our upper class boundaries, there's the cumulative frequency, there's the ages. So ages here, plotted at the upper class boundaries here, cumulative frequency on the vertical scale here. On these diagrams, on cumulative frequency curves, we use n over 2 for the median. So as the cumulative frequency goes up to 60, the median will be at 30. So we'll estimate the median there by drawing across to there and then down to there, and then we make an estimation based on the curve for the median age, and we get 39 years. So in 2005 we expected half the population to be over 39. We do a similar thing for the quartiles. 15 would be the lower quartile, and that comes out at 20 years. So cumulative frequency 15 because it's a quarter of 60, and that reads out at 20. For the upper quartile 45, and again that comes down there to 56. That then enables us to work out the interquartile range. 56 minus 20, 36. We can use the cumulative frequency curve to estimate how many people over retirement age. If, say, the retirement age is 65, how many people are retired? Well, we go to 65 here, working the other way around now. Read off the frequency, and 60 minus 51 million gives us 9 million retired.